Imagine walking into a high-end research lab, right? You've got the centrifuges spinning, the microscopes are, perfectly calibrated, and the lead scientist, the one formulating the hypotheses and designing the experiments, well, they don't actually have a pulse.
Right, which, I mean, for a long time, that specific scenario was strictly relegated to philosophical science fiction.
Yeah.
We just always assumed the human mind was the irreplaceable engine of discovery.
Exactly. But if you look at the landscape of research laboratories over the past year, that assumption has completely shattered. We are looking at an adoption curve that just defies historical precedent.
Yeah, the scientific method usually moves like a peer-reviewed freight train. Heavy, methodical, and incredibly hard to derail or accelerate. I mean, we like our protocol thoroughly tested.
We do. Welcome to the deep dive, by the way. Today we're dissecting a statistic that completely stopped me in my tracks.
The big one.
It really is. So according to the 2025 explanation study published by Wiley, which surveyed over 2,400 active researchers for those listening, the use of AI in daily scientific workflows skyrocketed from 57% to 84% in a single year.
Yeah, that means nearly 9 out of 10 scientists are now relying on machines to do their job.
9 out of 10 in 1 year.
Seeing that kind of market saturation in 12 months is practically unheard of in any professional field, let alone one as heavily regulated and, frankly, institutionally conscious as scientific research. It really signals a desperation to keep up.
And because everyone rushed out to integrate these tools so quickly, the entire scientific community is now facing what experts are calling a massive guidance gap. Institutions are scrambling to figure out the rules of the game.
They're playing catch-up, essentially.
Right. So our mission today is to navigate that gap for you. We have pulled together a fascinating stack of sources, including 2 landmark May 2026 papers from the journal Nature, a highly discussed preprint from the IREXIF database, and a massive January 2026 comparative study out of Scientific Reports.
All circling the exact same explosive question.
Exactly. Is artificial intelligence here to act as our brilliant, fearless research assistant, or is it systematically evolving to replace the human scientist altogether?
And honestly, the jump from a helpful tool to an autonomous replacement is a line that the technology is already starting to cross.
Okay, let's unpack this. Because to understand why the scientific community is suddenly hitting the panic button, we have to trace the evolution of the software itself. For a long time, we viewed AI as like a glorified search engine.
Or maybe a really fast proofreader.
Right. But our sources point out that in May 2026, 2 distinct systems fundamentally rewrote the scientific method.
Yeah, we moved away from the single large language model.
Mm-hmm.
Previously, you would type a prompt into a chat box and wait for a single linear stream of text, which was impressive, sure, but limited.
It hits a wall pretty fast.
Exactly. So the breakthroughs in May 2026 introduced what computer scientists call multi-agent systems. Instead of one AI working alone, the architecture creates a coalition of specialized virtual AI agents.
And they actually talk to each other, right?
They do. They communicate, they critique each other, and they pass complex tasks back and forth entirely without human intervention.
Wow. And the prime example from the Nature papers is this multi-agent system developed by Future House called Robin. I was looking at the breakdown of Robin, and it reads less like a software program and more like a highly efficient corporate department.
That's a great way to put it.
Yeah, so there are individual agents named Crow and Falcon, and their entire programmed existence is dedicated to literature search. They just scour millions of published papers in parallel.
Right, and then they package their findings and hand them off to a totally separate agent called Finch, whose sole purpose is data analysis.
Which is wild.
It is. That division of labor is exactly what allows the system to work end-to-end autonomously. Robin doesn't just read. It formulated a novel hypothesis, designed the experimental strategy to test that hypothesis, analyzed the raw biological data that came back from the physical lab, and ultimately found a successful repurposed drug candidate.
Okay, but how does a string of code actually invent a hypothesis? I mean, it's not having a eureka moment in the shower. We want to make sure we ground this in the mechanics for everyone listening.
Right, so when Finch is analyzing data, it is looking at multi-dimensional vector databases. It's essentially graphing out thousands of chemical properties and finding hidden mathematical correlations between, say, the molecular shape of an existing drug and the biological receptors in a human eye.
So it's mapping blind spots that human researchers simply couldn't see just because our brains don't process data in 500 dimensions.
Exactly. And that mathematical mapping yielded real-world results. Robin identified a glaucoma drug called rupasudal. and successfully repurposed it to treat dry, age-related macular degeneration.
Which is a major cause of global blindness.
Huge. And the system managed this entire pipeline, from the initial conceptualization to finalizing a manuscript for submission, in 2.5 months.
2.5 months for a process that normally takes a human pharmacology team several years and millions of dollars. But I do want to push back on the terminology here a bit, or at least clarify it for you listening. When the sources say Robin did this autonomously, human beings were still physically involved.
Yes, they call it a lab-in-the-loop framework.
Right. To me, it feels like a Michelin star restaurant.
Yeah.
The AI is the executive chef. It is coming up with the menu. It's sourcing the chemical ingredients. It is designing the plate. And the human scientists. I mean, we're just the line cooks, blindly chopping the vegetables and stirring the pots exactly when the chef tells us to.
That's spot on. The intellectual framework, the actual scientific reasoning, was entirely managed by the machine. The physical execution of moving liquids between test tubes was the human contribution.
Incredible.
And Robin wasn't a fluke. At the exact same time, Google DeepMind published their own breakthrough in Nature called Co-Scientist.
Oh man, here's where it gets really interesting. Co-scientists took a totally different architectural approach than Robin. Instead of just dividing labor down an assembly line, it runs a tournament of ideas powered by the Gemini model.
Yeah, it generates multiple virtual agents and throws them onto a virtual debate stage. These agents argue, critique, and refine competing hypotheses against each other.
And Co-Scientist uses an ELO-based ranking system to score which hypothesis is the strongest. Let's unpack that ELO system because it's brilliant.
It really is. ELO is the same mathematical system used to rank chess players.
Right, so just like a chess rating goes up when you beat a grandmaster, Co-Scientist pits two generated hypotheses against each other. It looks at the biological data, and whichever hypothesis explains the data better basically wins the match, stealing points from the loser.
And it runs these pairwise comparisons millions of times a second until only the mathematically strongest idea is left standing.
It's just mind-blowing.
And the winning idea in their trial was a drug repurposing candidate for liver fibrosis. When the human line cooks took that hypothesis into the physical lab, the drug successfully blocked 91% of a scarring-linked response in the cell.
91%. Filippo Menelacina from the University of Edinburgh reviewed this system and called it a jetpack for scientists.
A jetpack. I love that.
I do too, but a jetpack implies the human is still wearing it and doing the flying, you know? But if an AI can autonomously generate a hypothesis using a tournament of ideas, review 500 background papers in 30 minutes, design the experiment, and write up the publication figures, what is actually left for the human mind to do?
That is the big question.
If you are a scientist listening to this, you have to be wondering about your own job security.
Well, that fundamental shift in the daily reality of the scientist brings us to a major preprint published on the ArcZF database in May 2026. The researchers, Salatino, Sherp, Kreutz, and Vadati, analyzed this landscape and warned that the disruption isn't going to look like a sudden mass firing of researchers. It's a subtle psychological shift in agency. We are transitioning from the role of researcher as creator to researcher as curator.
Okay, so less painting the canvas from scratch and more walking through an art gallery deciding which of the AI's paintings gets hung on the wall.
Exactly. The machine synthesizes the literature, drafts the text, generates the citations. The human just reads it over and signs off on it as a gatekeeper.
But wait, if we're just signing off on the machine's intellectual work, aren't we just becoming ghostwriters for algorithms? That creates a massive accountability paradox. I mean, if a multi-agent system like Co-Scientist comes up with a hypothesis and I just rubber stamp it, who takes the blame if the science is fundamentally flawed or, worse, physically dangerous to a patient?
That is the nightmare scenario. But the legal and ethical frameworks have a definitive answer for that right now. Under the current guidelines set by COPE, the Committee on Publication Ethics, which sets the gold standard for global scientific publishing, an AI cannot be credited as an author.
Because it's just code.
Right. An algorithm cannot hold a copyright, it cannot hold legal responsibility, and you obviously cannot revoke the medical license of a piece of software if it commits malpractice.
So the human has to take the fall, even if they didn't actually create the work. You are legally responsible for the chef's menu.
Furthermore, this shift from creator to curator is creating a terrifying downstream effect on the entire ecosystem of human knowledge. When the cost of generating a highly plausible, professional-looking scientific paper drops to zero, you get a tsunami of
A
noise.
tsunami of noise.
Yeah.
And we're already seeing the early warning signs of this. The sources brought up a massive scandal that hit in late 2025 at NeuroPS.
Right. For context for the listeners, NeurIPS, the Neural Information Processing Systems Conference, is arguably the biggest, most prestigious machine learning conference in the world.
The gold standard.
Absolutely. And over 50 accepted papers at that conference were discovered to contain hundreds of completely fake, hallucinated references.
Oh, 50 papers.
Yeah, the generative models had drafted the text and fabricated citations that looked incredibly real, complete with fake authors and plausible journal titles.
And the human curators didn't bother to verify the references before submitting them.
Nope. And the peer reviewers missed them entirely.
Which is where it gets darker, because the peer review process itself is being hollowed out. The sources cite studies estimating that up to 21% of peer reviews at major conferences like ICLR, the International Conference on Learning Representations, might already be fully AI-generated.
Exactly. Researchers are using AI to write the papers, and the reviewers are using AI to evaluate those papers.
Wait, let's trace the logic of that loop. If multi-agent systems are writing the original research papers, and then the journals are using other algorithms to read, review, and approve those papers, haven't we just built an entirely closed loop?
Pretty much.
It's a machine echo chamber where algorithms are validating algorithms, and the human intellect is completely locked out of the scientific record.
And what happens is you end up polluting the foundational databases of human knowledge with highly plausible but completely unverified statistical noise. Once that noise is published, future AI models train on it, compounding the errors until human scientists just lose their grip on what is actually empirically true.
If you're hearing this and picturing a dystopian takeover of the research lab, you aren't alone. It is very easy to feel a sense of absolute despair for the future of discovery, but our sources do not stop at the doom and gloom.
No, they don't.
They actually pivot to map out the structural limitations of artificial intelligence. They demonstrate exactly why the human mind cannot be entirely designed out of the process, regardless of how fast Robin or co-scientists can parse data.
Right. There are hard ceilings to what predictive algorithms can achieve. And to understand those ceilings, we have to look at the January 2026 study published in Scientific Reports by Professor Karim Jerby at the University of Montreal.
The scale of that study is just incredible.
It really is. His team ran a massive comparative analysis, testing the creative output of leading generative models like GPT-4 against over 100,000 human participants.
100,000 people. And the results really parse out the difference between statistical machine processing and actual human brilliance. They used standard linguistic tests for divergent thinking, like the alternative uses task, where you have to generate a highly diverse, unrelated list of words or concepts.
And interestingly, the AI actually beat the average human on those standard tests.
Which makes sense mechanically, right? I mean, the model has the entire internet's vocabulary mapped in its neural network. It can pull disparate words together way faster than an average person.
Exactly. But the turning point in the data emerged when the researchers isolated the top 10% of human minds, and when they moved away from simple word association into richer, deeper, creative tasks.
So things like poetry, complex storytelling.
Yeah, and leaps of deep intuition. In those areas, the top-tier humans completely crushed the AI. The human mind left the machine far behind.
But why is that? If AI is essentially a master of statistics, perfectly calculating the probability of the next word in a sequence, why does it fail at true creativity?
So prominent computer scientist Peter J. Denning formulated a concept that explains this perfectly. He calls it tacit knowledge.
Tacit knowledge. Let's dig into what that actually means in the context of a research lab.
Sure. So explicit knowledge is anything you can write down. Data points, historical facts, mathematical equations, chemical structures. AI dominates explicit knowledge. But tacit knowledge is the vast, unwritten ocean of human understanding.
Like the feeling of riding a bicycle.
Yes. Or a veteran scientist looking at a cell culture and just intuitively sensing that the coloration looks off before running a single test. It's our lived sensory perception and our historical culture. An AI can scan 1 million medical records and explicitly tell you a statistical correlation exists, but it cannot grasp the why behind human behavior.
Because it doesn't actually live in the world.
Right. It cannot navigate paradigm-shifting anomalies that exist entirely outside its training data because it doesn't actually experience the physical world.
It only knows what we have explicitly fed it. Which brings up a massive vulnerability. If an algorithm's entire reality is constrained by the datasets we provide, it inevitably inherits all of our historical flaws.
Unavoidably. Generative AI scales human bias. Racism, sexism, and cultural prejudices are deeply baked into historical, medical, and social data.
The reference manual on scientific evidence has a quote that sums this up perfectly. Numbers are not neutral. Data collection is a human choice, and those choices carry bias.
And when you run those biased numbers through deep learning algorithms, you hit the black box problem.
Oh, this is a big one.
Huge. Deep learning relies on artificial neural networks with dozens of hidden layers. Billions of parameters interact simultaneously. The logic pathway is smeared across the entire network, not localized in a simple step-by-step code.
It's just math on top of math.
Exactly. It is so mathematically dense that even the programmers who built the system cannot explain the exact sequence of how it reached a specific conclusion.
Which is an enormous liability. If a hospital is using an algorithm for clinical diagnostics, or a judge is using one in the criminal justice system to calculate recidivism risk, and it makes an error that harms someone, we can't even look under the hood to figure out where the math went wrong. It is completely opaque.
Yes.
And if you are that researcher as curator who just signed your name to that black box conclusion, you are now legally and ethically responsible for an error you fundamentally cannot explain.
You carry the liability without possessing the methodology.
So, what does this all mean? We know multi-agent systems possess this incredible, terrifying speed. But we also know they have deep structural flaws. They lack tacit knowledge, they amplify historical bias, and they operate as impenetrable black boxes. We really need a functional framework to navigate this.
We do, because we don't want an AI winter where institutions get terrified and just ban these tools.
Right, but we also cannot accept an AI replacement nightmare where humans are pushed out of the loop entirely.
Exactly. So major publishers like Wiley are coalescing around a practical solution called the Human-AI Teaming Model, frequently referred to as the Centaur model.
The Centaur. Half human, half machine, working as a single unit. To make that work on a daily basis in a lab, you have to frame the psychological relationship correctly. You cannot treat the AI as an infallible co-author. You have to treat it like a brilliant, tireless, but incredibly naive junior intern.
That's the perfect analogy. If you hire a brilliant junior intern, they can process massive amounts of literature for you overnight. But you would never copy and paste an intern's unverified draft directly into a final journal submission.
Yeah, never. You'd be risking your entire career. You set the initial parameters for them. You relentlessly fact-check every single claim they bring back. You apply rigorous human skepticism to their output.
And to formalize that intern relationship, Wiley has laid down 3 vital principles for the ethical integration of AI in research. Principle number 1 is transparency first. This means you must disclose your AI use granularly.
So you treat the AI exactly like you would treat a piece of statistical software, like SPSS or R.
Right. You state openly in your methodology, I use this specific multi-agent system to parse this specific database.
Okay, principle number 2 is protected peer review. This one is critical for safeguarding the future of intellectual property. You must never upload your unpublished manuscript data to public large language models.
This happens so much. If you feed an unpublished, groundbreaking biological finding into a public LLM just to check your grammar or format your citations, you have inadvertently absorbed your proprietary data into the machine's global training set. It is a massive breach of confidentiality.
Huge mistake. And finally, principle number 3. Accountability. No matter how much heavy lifting the multi-agent system did, the human remains 100% legally and ethically responsible for the final product. You are the ultimate safety net. The AI is the tool. You are the scientist.
Adopting this Centaur framework allows researchers to reclaim their intellectual leadership. We delegate the routine, repetitive tasks like mapping chemical vectors in minutes to the machine.
Right.
And that delegation frees up the human mind to do exactly what that 100,000-person creativity study proved humans do best.
Deep critical analysis, nuanced ethical judgment, relying on our lived, tacit knowledge to drive true paradigm-shifting creativity. To summarize this deep dive for you listening, artificial intelligence is not an existential threat to human researchers, but it is an absolute, undeniable threat to the traditional way we conduct and validate science. The old way of doing things is over.
It really is.
The choice is now entirely up to you whether you want to coast as a passive curator mindlessly signing off on the machine's echo chamber, or step up as an active ethical creator, managing the algorithm like the powerful tool it is.
It demands a conscious choice to maintain your agency in the lab.
Absolutely. But before we wrap up today, I want to leave you with one final lingering thought to mull over on your own. It builds on everything we've unpacked about the speed of these systems versus the limits of human understanding. If we are stepping into this role of the ultimate ethical gatekeepers, relying on our tacit knowledge to verify the machine's work, what happens in 5 years? What happens when a multi-agent system generates a life-saving medical hypothesis that is so mathematically complex, no human mind possesses the tacit knowledge to actually verify if it is true? Do we blindly trust the black box, or do we walk away from the cure? Keep questioning, keep critically analyzing everything you read, and keep exploring. Until next time.